whenever you see one of these colons, there are other structures in Python other than the for loop that use this, and we'll get to at least another one of them later. Anything that's indented after the for loop will be part of that. So anything that's indented directly.
And it goes on. So it explains what range does, how it creates a list, and how it iterates and sets the variable to each item in the list and so on. And so after we've got all the videos, they've got their worksheet there. And if I open up one of these code files, some of them are very, very basic, don't have much in them at all. And then other ones are heavily scaffolded, depending on what they're attempting to do. Okay, wrong file to open it with, wrong thing to open it with, I mean. So I'll just save that instead. Okay, so that, for drawing a circle, is what the students are given. So I create a window that's 500 by 500, I create the turtle for them, but there's not much else, okay, because they don't need much else. When I get to examples where they have to detect the mouse click, I detect the mouse click for them, and they have to change the colour of the dot where the mouse clicks depending on what quadrant of the screen it's in. So they have to start going, well, okay, is my X location greater or less than 0? Is my Y location greater or less than 0? Use my if, else. So I use that Boolean logic to determine what dot colour. That's heavily scaffolded, because there's a bunch of stuff that needs to happen to be able to detect the mouse click and pass it to them in an easy way. So they just write that bit of logic. So some of them are heavily scaffolded, some of them just look like this, depending on what they need to achieve. So inside there I have the worksheets, I have the teacher's files. Oh, this is the thing I didn't show you as well. If I go into the teacher's files, I go into lesson 2 and I open one of these. That's the answer. So for every question that the student has, I've got the exemplar answer. And again, there's more than one way to the top of the mountain, so sometimes their answer will be different, but this gives you an exemplar of what it possibly could be, a good example. So, if you're teaching Python, I'm handing you one possible avenue where everything's provided to you from start to finish. And this is dangerous, asking a question that I don't know the answer to, because I haven't asked. How did your turtle unit go?
Yeah, it was really good. Yeah, having the answers was super helpful because I was a bit nervous because I didn't know what exactly I was teaching the whole way through. I was pretty much just a step ahead of the kids. But I went through it, like you said, as a student at the start, and that was really helpful because I found all of the things that my students probably were going to run into. And then when they asked me, it looked like I knew what I was talking about, but it was just because I was running into the same error about 6 hours beforehand. So yeah, it was really good. Kids liked it. No problem.
And now you've done one run of it, next time you do know exactly what you're talking about. So just before I move on to game frame, I do want to explain why I've gone the Python route. Apart from very simple syntax where you don't see curly braces and semicolons, const int, or any of that sort of stuff, it's very simple syntax. There's a couple other reasons. Syntax is a thing I don't really care too much about. Okay, so at university we always used to say you teach concepts, not languages, and you should be able to change languages. And the example I give kids is when I was working in industry and I needed to talk between servers, I had to have the billing system in Sydney talk to a server in London, which spoke across to Los Angeles and back again, and I had to talk between them. I sort of researched what the best tool was, and the best libraries and the things that I needed were in the language called Perl, and I'd never written Perl. 3 days later I had the first version up and running. And that's because I understood the concepts. It was just a matter of changing the syntax and learning what the libraries and APIs are. So syntax isn't a big deal to me. That's a secondary consideration. That's the thing where we take our concept, our algorithm, which is the important part, planning it out, understanding the mechanism, and then this is just a way of expressing it. And we can express it in whatever language we want. So I want to minimize the syntax. So using Python minimizes that syntax to a certain degree. Let's have a look at web development. What do you need for a web development to actually have a web page? So you probably need server-side language, PHP, maybe something else, Python, Perl, whatever it is. I've even seen someone use C++, that was horrible. Not in school, but just don't do that. So you've got your server-side language, you've got your HTML, you've got your CSS, you've got your JavaScript, and if it's data-driven, you've got SQL. That's 5 lots of syntax you need to remember. That's 5 lots of syntax that could trip you up when what you really care about is logic, algorithms. I teach Python and SQL. That's it. So when they're using logic, it's Python. And they've been doing it since year 7, in the best case scenario. SQL, they're working with a database, obviously they're using SQL. That's it. Okay, so that was a real appeal to me because that's just a barrier that we don't care about. We care about algorithms, we care about logic. We understand, we want to talk about relationships and databases and so on. So the path I take is we start off doing Turtle in Python. Well, we start off with Edisons, driving little Edisons around in year 7. It's very, very basic Python. But I've got year 7s writing actual Python using for loops, using if statements, and let me just get this up quickly. You probably can't see that very well, but we've got some little bots there and they've lined up some books. We just did that last week. And there's a little robot there driving through the books there, making its way through the path. Oh, hit a book, never mind, turn around, keep going. All written in Python. That's year 7. Is that the Edisons? It's the Edisons, yeah. So then we go on to year 8, and we use the PyBoard. So it's control systems, we can work servos, turn wheels, whatever it is. It's not that much different to the Edisons actually, but they're still at that age. I don't think they're ready to go on to the object-oriented and things so on. And then we get to year 9, and we work our way up. So currently, my year 11s, if I can just show you, and I'm not doing this to scare or intimidate you because that's the opposite of what I want to do. I'm hoping that it'll kind of inspire you to see what people can get to. There we go. Okay, so you can use game frame, which I still haven't got to yet. I'm about to get back to it, but I just want to again show why I'm talking about Python. You can use game frame for 11 and 12. There's no problem with that. I don't because I've covered all that stuff in year 9 and 10. So they would have done game frame in year 9. They would have done artificial intelligence with the bots in year 10. And then coming into year 11, the assignment I've given them is to write a stock market simulator. So a very basic stock market simulator. And I give them this file. So I give this to them in week 3 of year 11. And again, this isn't to intimidate or scare you or think that you should be doing this. I'm not saying that at all. I just want to show you the level they can get to. So this is an abstract class, or an interface class if you come from a different language like Java. And it specifies what they have to implement. So the way I progress through year 11 and 12 is I give them this interface file, which they inherit from and create their data store. Okay, so what we've got is we've got this stock market simulator, so therefore it has to have a user interface, and this one is a command line interface for term 1, year 11, and they have an entry into the program, our main. So our main creates a command line interface and it talks to the data store. So a user might get a menu in the command line and it'll say, I want to buy a stock, what's your name, what stock do you want to buy, how many of them do you want to buy. It then interacts with the data store calling its functions to do what it needs to do. So it's all modular. Now I use this interface file to one, provide the data structures. So they don't create the data structures, they use this, and I've got maps, and I've got a map or a dictionary, map, dictionary, whatever language you want to use, dictionary with a list that has a dictionary in it. So we're only using 2 data structures, but we're using them in interesting ways. And they then have to create their application which gets those data structures, but then are forced to use this interface. So they must implement these functions. So I lay out all the functions that they must have to be able to interact with the stock market. And then they change the prices behind the scene up and down so they can simulate it. So the scenario is our economics department want to teach their students about the stock market, write a basic stock market simulator for the students to use. And I give them the interface, and there's a really good reason why I enforce that interface, is because in term 1, they create this. Some of them did a fantastic job. They used ASCII art, and they had encoded logins and things that I never asked for. So again, you don't put restrictions on them. It's really interesting to see how far some of the students go. They get obsessed with the coding. So they implement this. And then we go, okay, we're on to term 2, which I'm about to give them. And they have actually, that's not completely true. There'd be a controller in the middle here as well. I'll just call that main to make it simple. So it's the same sort of thing, but we don't edit this at all. So our back end is still working. We've got an interface, an API that's reliable. Everyone's implemented the same thing. If I want to run a testing suite on it, I don't have to do any work for marking. I can find the errors by just running my code, because I know they've implemented that interface. So that covers the graphical user interface. They've done their planning for this, so that's all that Unit 1 stuff. And then when we get to Unit 2, we leave all that there. We get rid of the data structures, and we replace the back end with an SQLite database. So you can see it's modular, like I said at the beginning of the talk, but it's not siloed. So everything requires everything else, and it's very well planned out, object-oriented, modular code. When we get to Unit 3, guess what they're going to build? They've already got a nice layout of what they already need to do. They've already got samples. They've got example code, and then I give them a different scenario. So it's a translation of those skills from one domain to another, but they have all the skills. Now, again, that's only because my guys have already gone through the stuff in Year 9 and 10. I'm not suggesting anybody does this, and I'm not suggesting any of you students should be up to that. I handed them this file in, it was like week 2 or 3, I think it was week 3. So they have to be prepared, right? You don't hand that to somebody after 3 weeks of learning to code.
Did you allow any students who've never done Year 9 and 10 in your program?
One student, yes, and he's a very hard worker, and he puts a lot of hours in and a lot of effort, but he's still well behind the 8 ball. But I give him a little bit more scaffolding because of that. He is getting through. He is being successful with it, yeah, but in general, yeah, I wouldn't go down that track if you've got somebody for the first time. And again, I hope I haven't scared everybody off. That's not what I'm here today to preach. I'm not saying to do this. I'm just showing you where we can get to. And it makes me really excited because okay, so I really got to get on to GameFrame and help you install it, particularly the EQ teachers. So yeah, sorry, that was a small digression, but this is why I'm so excited about what we're doing in Queensland, because one of the things I got back is the teacher that ran with GameFrame and Turtle last year at Marymount College. She went down to PyCon, which is the Python conference for Australia, and they've got an education stream. So you've got all the hardcore Python hackers there, but on the side you've got the education stream, so all your teachers go there and they talk about how they're using Python as well. At the end of that conference, she wrote to me and she said, she went down and looked at what they were doing, and she said, I can see now, paraphrasing because I can't remember exactly, how far more advanced our students can be using GameFrame than what I'm seeing running around the country. And as I said, after one term, so about 6 to 7 weeks of Turtle, the last few weeks of term, I go into GameFrame, say first 4 weeks of term 2, this is for Year 9s, they're completing full object-oriented coded games in GameFrame. Okay, so GameFrame is the next step after using Turtle. So in Turtle I get up to functions. So we've done loops and assignment obviously, we've done Boolean logic, we've even gone to functions, parameters and return types. We've done all that sort of stuff, but we haven't done objects. I introduce objects using GameFrame. That's my dog, Toby. So if you go to this web page, you don't need to because you've got everything in that shared folder. But I've got the setup, how to install Python, how to set up GameFrame, all there on the page. And if you're not in EQ, that will serve you fine and it will work perfectly for you. If you are, it won't. And I'll get back to that in a second. So if I go to Veggie Samurai, what I have is I've got an example game and a PDF tutorial that steps through making a basic GameFrame game. These are your artifacts. You've got a bomb and a carrot, and the idea is you've got veggies bouncing around on the chopping board and you have to cut them. Once you click on them and you get all the carrots, you go to the next level. Yeah, it's a completely unique game that nobody's ever thought of. It's veggies, it's not fruit, okay? Samurai, not ninja. Alright, so you can step through this, and this is what Talia was stepping through the other day. She did in between classes and got the full game running. So it shows you the layout. So again, those of you who know Game Maker, you'll recognise that we've got a sounds folder, a rooms folder, an objects folder, and an images folder. So all the objects, all the images that are used go in the images folder, any sounds that are used go in the sounds folder, and we really work in the rooms and objects. So we define a room, we say this is level 1, or this is the kitchen, or this is the lounge room, or whatever it is, and then inside that we'll put objects. So the individual objects will be the bombs or the carrots. And then the framework takes care of, is a carrot, has it been clicked on? Has it interacted? Has it hit a wall or something like that? And it will inform the user. So there's a lot of work going on behind the scenes in the code that I've given. There's a folder up here called GameFrame, and that holds the whole framework. So I was considering at the beginning how I'd lay this out. Would I create a library that they just import and start using? And I thought, no, I don't want to do that. I want the code to actually be part of their project. And the reason is, they don't have to actually edit that or ever look at it. They can just write their game in here. But sometimes I get questions, well, how does that actually work? So when I just say register for a collision with this object, and it tells me what's actually happening. And not many, but a few students do go in there. Occasionally they edit it. I had one student, actually he was a Year 10 student, went in there, improved the framework to the point that I actually included it in the code still there today for all you to use from a student. So he went in there and added code. If you doubt it, go to my Git page and you'll see the pull request from the student and how I merged it into my code. And so there's a student that 12 weeks prior had not written a line of code and now added to the framework. So I leave it all in there. They can look at it, go mess with it, break it, and just override it with a new version. Okay? You can never break anything. Go play, enjoy yourself, break stuff. Okay, so you've got this tutorial that steps you through. It explains all the different files, what they do. There's a global file that sets the lives. We've got a progression. You put in what your rooms are into this list, and the framework will automatically figure out which files it needs to run. It'll run that one, then that one, then that one, then that one. You can jump around randomly as well, but I give them a structure to begin with. Okay, so you can step through all that. If I go into these examples, I'll show you some codes. Oh, the same one. We'll have a look at Splat Attack. Alright, so Splat Attack, just like any other GameFrame game, has all of that structure there, and then we just edit within that. So what I'll do is I'll fire up my editor, and then after I show you this structure and how it works, we'll get it installed on your machines, for those who want it installed on your machines. Okay, so having a look at this structure. Again, you'll probably have to go through the tutorial to really follow all this. You can watch the video afterwards, it'll make more sense later if you've done the tutorial. This is our layout. So these are the rooms that I have for this particular game, and these are the objects that actually move around inside the game. This main controller is where the whole game runs from, but the students never touch that. They just know that that's the file that they have to run to get it to go. If you have a look in that, that's just my code that sets up all the high game stuff. It's got the main game loop. It figures out what room that they've said is next, and it uses some reflection to open up that class and create an instance and run it and do all that stuff. Kids don't need to know about that at all, unless they're really advanced and they want to. All they need to know is that's the one you run. Okay, so this particular game, Splat Attack, I'll use the touch screen to be easier. So I'll play this. So this is the first room. You can see the floorboards of the house. It's not my house, we've got lots of bugs. It might be based on one, so. I'll just play one level. Okay. So one of my worries was that the kids would end up playing the games more than they would be writing them, but it actually turns out not to be the case. They can't wait to put the next feature in or make it do the next, put the boss in there or whatever. There's always a boss for something. There always has to be a boss. Okay. So we've just got these objects. So we create a spider and we set its speed and direction. We create it outside of the screen and it comes running. And once it gets down the bottom, I actually just change its X and Y location to another random spot across the top. And they just keep coming down. Each one's worth a different amount, depending on how fast they move. And it's got room progression. So it had that intro screen where you can quit, progresses to the next room, which was the floorboards, tells you what your score is at the moment, progresses to the next room. So there's quite a lot going on there, and it gets to the very end and gives you your total score. Yep.
I reckon if you had a few cockroaches around the state of origin times, it would be a real big start.
All right, definitely doing that. All right, so if we go have a look, let's have a look at one of the rooms. Okay, so again, if you're one of the people who are starting out, Python's all new to you or whatever, don't get freaked out about this. It looks really impressive, but when you've gone through the progression and you get to it, it's actually, most people find it straightforward, at least to do the basic stuff. So if I have a look in here, I say this is the room, I get them to just to do basic stuff like make sure the class is the same name as the file. I don't get to the level where you can have multiple classes in an individual file and complicated imports or anything like that. I keep it very simple. It imports from a level. So I just explained to them that this is a level. So we define it as such and then we extend that. So there's certain things that are common to all levels. It creates that and then we start extending it. So I'm talking about inheritance without really going into what inheritance is. And just like a room, when I create a room object, I just say, we've got to tell it that it's a room object. And so it gets all the attributes of a room object and then we start making it do its own things. So we can set background of the room. I've got a splat sound there that I can play when I want to. I've got a bunch of different images that I can use. So I put them here rather than into the individual objects because I found I only needed one insect object. And I could give it its image, or I could give it its speed, and I can give it its score. So I only needed one of them. So I loaded them up here. Quite often they will be in the object itself. I've got timers. So I can say, wait 60 frames, it runs at 30 frames a second. So 30 times your screen updates every second. So if I set it for 60, wait 2 seconds and then run that function. So I've got timers as well that I've built into the framework to make it really easy. So that was one of the things I looked at when I was using Pygame. I'm like, well, how could you set a timed event? And it was really complicated. So I went, no, I'll just build a timer into the framework. So all they have to do is say set timer, how many ticks, and what to run when that timer runs out. So we've got functions here like add an ant. So I create an insect object, I give it the splat sound, I give it the ant image, and then I wait 120 frames and I call the add ant again. So it's continually adding ants. Same with the roach and the scorpion. So I kick those off, the spider. So that's basically setting up what the room is. What does the room look like? What's its background? What are the things that are in it? Create them. But if we go up here, this is what an insect actually is. So I need to know what room I'm in. I need to know my X location, my Y location. I'm importing the sound because I figured in the future the room would control which sounds they were. So different insects, even of the same type, might have a different splat sound. I didn't get to that. But it's just an example anyway. So the image, the insect image as well as the splat image, so they could have all different splat sounds. The speed as well, so the speed that they're coming down. So I can define my object in there. Now, the initial way that students normally do it is they just have a cockroach and a spider and whatever, they're all their own objects and they've got all their own stuff internally, and that's completely fine. I've got different game examples, I think I've got like 7 or 8, that all do things differently. And this one shows how you could use one sort of object and polymorphize it so that it could actually become different objects. But in my other games I don't do that. So I've got a bunch of different games that I let them look at. So these are some example games. We've got Flailing Sparrow. For those who don't know this totally original game, you might confuse it with Flappy Bird. So it's got the bird actually animated, so it's flying, and it can fly in an up position, a down position, and a neutral position, with the wings flapping. So that will show you how to do character animation. So these are all incomplete games with little features of different things. So when they go to create their own game, I say, sure, take one of these if you want. If you want a maze-like game, take Labyrinth Walker. A lot of people make Pac-Man from that. If you want a platformer, take Joe's Escape. But it's an incomplete game, and the features you want, you'll find in the other ones. So they need to go look at the code there, and that transference of knowledge shows that they have understood. So if they go get the code from there, they can't just copy and paste and make it work. They can copy and paste and edit and make it work. So it shows that they do actually understand it. You also give them a leg up due to time constraints and just help with their learning. And then they'll go and want to do something that's not there anyway, and they'll implement their own more advanced features. I'll just show you maybe, I'll show you 2 more, because I think these are pretty cool. So I'll show you that one, and that one. These also seem to be fairly popular. Alright, so I won't open it up in the editor, I'll just run it through the command line. Which one will I do first? Okay, so this is paddle demolition. It's got the buttons the same to be clicked on. But now we've got something where it follows the mouse. It's my time's up, is it?
No, keep going.
No, you've got 15 more minutes at least.
Oh, okay. I was rushing the end of it. We good to go? Okay, so this one, if I move the mouse, the paddle moves with it. So, again, there's another example. If I need something that tracks the mouse, maybe some of them have like targets, so it tracks your mouse, put the target on something, and then you hit a button and shoot towards the target, things like that. So if you want to track a mouse, this game has an example of tracking a mouse. So we've got a ball moving around. If I hit on that side of the paddle, it goes back that direction. If I hit on this side of the paddle, it goes back that direction. Some of the bricks take 2 hits. So the blue you've got to hit twice, it becomes shattered. The red you only have to hit once. Okay, and restarts. Okay, that's got a couple of levels too. And the other one I wanted to show you was War Aviator. Okay, again, totally original game, War Over Air. Some people think it's 1942, but okay, so this is a vertical scroller. That's again something that's built into GameFrame. You set background image and you set scrolling to 1. And it will just set the background to scroll. It will create another version of the background and just do that. So the bottom has to match the top. It's a bit laggy because my laptop goes into power save mode when it's not plugged in. So that one has sounds. So again, all these different example games have little snippets. I've also got a full API document that's included in that folder. So if I go back to there, not that one. Okay, so I've got the GameFrame API. So I wrote this up to match the features that I built into the framework. So again, it explains what rooms are, what objects are, what the different files are. If I scroll down a bit, okay, this is a level. So this explains what the different things in the level are, such as you can set a background. So it explains what they are, and it gives you an example of how to use it. So if I want to set the background scroll speed, then that's the way I do it. And I put the speed in there at 5. So I can set how fast the background scrolls down as well. Load sound. Sounds are really easy. If I've dropped the sound file into the sound folder, I just say load a sound, give the name of it, put it into an object, and whenever I want to play it, I call that object and say play. So it's made it very, very simple. Deleting objects from the room, you can just delete them, very simple. And then there's the timer that explains how you wait a certain period of time and then call the function. So I've got the full API document there as well. I found the students generally are quite resistant to using this at first because it's so much easier to say, "Sir, my program's broken, can you fix it?" And I walk over and say, "Ah, I see the problem. What is it? What is it?" "Ah, we need to look on page 3 of the API." And then they get in the habit and they start actually using this to look up how different functions work. And even the depth, for instance, if I've got 2 sprites on top of each other, which one do I show? Because in our maze we've got like hidden doors. You've got all the bricks and you can't get through the bricks. But one of them is actually a different type of brick and you don't know it. And you can actually slide under it. So you can set the depth of objects so that one's above the other. Yeah, so we've got all that stuff there too. Alright, now installing this, I'll assume that you've gone through the process of installing Python because it's fairly straightforward, given everyone's on Windows 2. It's pretty much next. One thing you've got to be really careful of is on the very first page of the installer, you click the box that says add to path, because we need to be able to find it from the command line. So you add to path. The next step, if you're not in EQ, is to say Py for Python, M for module, and pip is the Python package manager. So if I need extra code or libraries that aren't shipped with Python, I can get them by just running a command. It'll go to the internet, drag them all down. Command prompt, yeah, not pip. But I'll explain that in a second.
Catholic CE Net schools will also have this blocked as well.
Oh, will they? Okay.
We don't have access to that.
Okay, so if you have Python installed,
No, we can't access modules from.
yeah, this is
Just tether your phone and get around it.
oh yeah, you don't want to do that with 30 students. There is a way around it in EQ as well, but you also don't want to run around to every student's type stuff in. So I'll go through that in a second. So if you're in a sane environment, like home or tethered, you just use the package manager and say, Python, I need the Pygame libraries. So if you've installed Python and you run that command, you have everything you need to write the game frame of this game. And then you just unpack GameFrame and start developing. Okay, it's as simple as that. If I'm in EQ...
An alternative way of doing that.
Yes, I'm getting to that now. So if I'm in EQ, and I'm a teacher, not a student, I can say, we have a proxy, and that proxy is my user with my password at proxy2.eq.edu.au on port 80. So if I'm a teacher, not a student, and I want Pygame, I can just add the proxy on, and it'll actually allow me to install it. So in worst case scenario, you could grab a student's computer, make sure they're not looking at the screen so you can type your password in plain text, and install it. Occasionally I do that if I'm in a rush and I've got one computer, I'll just grab it right away, install it, get rid of the history, and then take it back home. The third method, and this is the one you'll need if you've got a restricted environment. If I go into that set of resources that I've given you, and I go into Python packages, I've kept it with just the one package at the moment because I didn't want to confuse anyone. Soon there's going to be about 6 there because I use them when I do my desktop development. Because I use a widget set called Qt, or Qt is the way it's pronounced. So Python with Qt, we just install some additional libraries and do desktop development. But for now it's just the Pygame. And the way you install that if you're in EQ or another restricted environment is you download the actual library itself. So I've gone and got this for you already. There's all different versions of this depending on what version of Python you're running. So if you are in a restricted environment, you want to install 3.7.0 because that's the file that I've given you. It matches 3.7.0. In time I'll update it. If there's a new major release, I'll update it as well. But when it's just minor releases, it's easier for me just to say use this version. Okay, so if you've got access to pip and you don't have a restricted firewall, use whatever version of Python you want and just say pip install Pygame. If you are in a situation where you're restricted, use Python 3.7.0 and I give you what's called the wheel. The wheel is a library that's for Python. It's got a WHL extension on the end. And we can install that manually. And it's confusing the first time you do it, but simple as anything after. So I put a little document there that showed you how to install it. Okay, so it tells you must have Python 3.7.0 to install the wheel. Now, on our computers, they actually put the home drive on D, not on C. So the main system's on C, but then the students' directories are on D. So I switch to D and go to the desktop. But that's the command you have to run. So if I just take that, copy that, go to my terminal and right-click after I delete this. So if I right-click here, it puts that in for me, but I do need to go back here and change the username. So mine is stux63, and then if I run that, it'll work. Oh, except for one thing, I need to be where that file is. So if I put that on the desktop, for instance, then I'll need to move to my desktop. Okay, and then I'd run that command again. And if I go back and change the username, okay, so that's where the file is. I don't have it sitting on my desktop at the moment, but if I had that file sitting on the desktop and I hit tab, it would have completed it. I press enter and it'll actually install it. So the first time it's annoying, but the thing is, once you've done it once or twice, or what, 30 times you did it for your lab, it's super easy. I walked through 2 classes last week, and within about 50 minutes, everyone was up and running and able to code in Pygame and run some of the example code. So yeah, this looks like a monstrosity, but it's what we have to do to get around their stupid proxy rules. So we're still using pip to install it, but we're doing it as a local file and just installing it that way. And after that, everything works. You wouldn't believe how many teachers across Queensland have written to me and said, we can't get Pygame. Even people who aren't using my stuff aren't using Game Frame. And it's actually quite simple once you've done it. Alright, so there's food here and you're all getting restless, so I'll leave it at that. You've got the video which I'll upload to YouTube, so you can go back and you can look at that, how that command was run again if you like. I'm available to help you now or in second break for a little while. I have to run not long after lunch starts. It would have been nice if I could have got it all up and running on everyone's machine who wants to go that way. But if you need anything, you can email me, My email address is there. I'm more than happy to help everyone. And I always get the same thing. Teachers are always, I don't want to bother you. You've done enough already. I feel like I'm being a pain. We're all educators. The best type of students are students who actually want to learn. And they're usually very much teachers who want to use some of the stuff that they're having trouble with. So I'm more than happy to help. It's the thing I love to do. And I love to see my code out there as well. So please don't feel like you're annoying me or it's a hassle. This is really not. Okay, any questions? Yes?
You know when you've got a desktop,
Yep.
if it's installed on the, if one is installed on the G drive, you point to that.
Yeah, right. So when you normally go into Drive, I'm not sure what mine's normally on. I don't think it's on C because it's restricted. Oh.
Mine's on C.
Okay. So whichever drive you're on, you just type that drive with a colon, and you'll go to that drive.
Okay.
And then once you're at that drive, you use CD for change directory, and you go to wherever your file is.
Okay.
Yeah, and once you're there, you run the command, and it'll install that file. Okay, guys, if I can just ask one more thing before I go. If I can get everyone's attention for a second. If I can just get everyone listening for a minute. Just 2 quick questions. Be honest, you won't hurt my feelings. I just want to have a quick show of hands. Who thinks that they got something out of there that they can actually use in the classroom, out of that talk? Okay, brilliant. Who would contemplate using at least some of the software that I've written, including my query tutor? Okay, brilliant. So you've got my email address. Make use of all the stuff I've given you. Thank you.
Thanks, Steve. Are you happy to help anyone out during morning tea?
Yeah, absolutely.
Who's got some stuff they want to do on the laptop? So morning tea is just a scone and some fruit. If you wanted to bring it back to the desk and get Steve to help you out with some cool stuff, we'll have about a half-hour break.